Alright, so welcome to the first problem. This problem is going to be about empirical and molecular formulas. So problem says the following. An organic compound X has the following composition by mass. It is 62% by mass carbon and 24.1% by mass nitrogen, with the remainder being hydrogen. Part A asks us to determine the percentage by mass of hydrogen and the empirical formula of X. Part B asks us to define the term relative molecular mass. Part C asks us to determine the molecular formula for X if the relative molecular mass of the compound is 116. So let's tackle part A. The first section of part A says to determine the percentage by mass of hydrogen. For this, we know that compound X is composed by carbon, nitrogen, and hydrogen. And we have the percentages by mass of carbon and nitrogen. So we know that the total is 100, and we know that the remainder of the addition of 62 and 24.1 must be the percentage of hydrogen as it is the remainder. So the way to tackle it is subtracting from 100 the addition of the percentages by mass of the other two elements, which are carbon and nitrogen. You add 62 plus 24.1 and you subtract that from 100, getting 13.9% by mass of hydrogen in this organic compound. So there you would have the first section of part A of this question. The second part says to determine the empirical formula for X. And for this, we want to know how many moles there are in the compound of each of the elements. To do this, we must divide the percentage by mass of the element by its relative molecular mass. So for example, here we have carbon. We know that carbon covers, as it's said, 62% by mass of the compound. We divide that 62 by its relative molecular mass, which is 12. We get 5.16 moles. We do the same with nitrogen. We get the percentage, which is 24.1. We divide it by the molecular mass, which is 14, and we get 1.72. And the same with hydrogen. We get the 13.9 that we obtained from the previous slide. We divide it by the molecular mass, which is 1, and we get 13.76 moles. Once that is done, we need to find the simplest whole number ratio, as the empirical formula is the formula with the lowest number ratio in the subscripts of the elements. To do this, we divide all the results we obtain from the moles by the lowest number. So the lowest number from 5.16, 1.72, and 13.76 is 1.72. So we will divide the three results by 1.72. If we divide 5.16 by 1.72, we get 3. If we divide 1.72 by 1.72, we get 1. And if we divide 13.76 by 1.72, we get 8. And therefore, we're able to find out that the ratio is 3 to 1 to 8, having the same order as it is stated above, carbon, nitrogen, hydrogen. Now the next step of that is to transform this ratio into the subscripts of the elements and obtaining that the empirical formula of this organic compound is C3NH8. Now, part B asks to define relative molecular mass. This is not mathematical, but it's also necessary and included, so we'll answer it. Now, there's two possible answers to this question. The first one is the relative molecular mass of a compound is the mass of a molecule compared to 1/12 of the mass of one atom of the carbon-12 isotope. That being the more conceptual way of putting it. And another possible answer is stating it mathematically in terms of an equation, which would be the average mass of a molecule divided by the mass of 1/12 of one atom of the carbon-12 isotope. You could state it both as a sentence or as a mathematical formula and they're both correct, they'll give you points for them. Now part C says that if the molecular mass of the compound is 116, to determine the molecular formula of X. Now, remember that the difference between empirical formula and molecular formula is that empirical formula is with the lowest number ratio of molecules and of elements in the compound, and molecular formula is the actual number of molecules and elements that are in that compound. So, to tackle this, first we need to obtain the molecular mass of the empirical formula. Now, we know from the previous exercise that the empirical formula is C3NH8. So let's go ahead and find the molecular mass of that compound. We multiply 3, which is the subscript of carbon, times its molecular mass, which is 12. Would multiply 1, which is the subscript of nitrogen, times its molecular mass, which is 14. And we would multiply 8, which is the subscript of hydrogen, times 1, which is its molecular mass. If we add all that, we get 58 grams per mole. Now, the exercise is telling us that the real molecular mass of the compound is 116. Now, we must identify that 116 is twice 58. So the real molecular mass is twice the empirical molecular mass. So the ratios will double. So that 3:1:8 ratio we obtained in the molecular formula, we need to double that, as seen in this mathematical relationship from the masses. We would double the ratios to get the ratios for the molecular formula. So the ratio of 3:1:8 doubles to 6:2:16, and we get that the molecular formula is C6N2H16. That would be the end of this video. You have the presentation in the description as a link if you find that useful. I hope it helped, and I hope you understand this exercise and how to solve for empirical and molecular formulas. Thank you.